those ones at the end were a little bit more difficult. So we'll take a look at those, ladies and gentlemen. Then we got to do some more rounding or some rounding today with sig figs after we look at some special cases. And that'll get you ready for your quiz tomorrow. So, all right. Let me get attendance. All right, good. You guys are not that hour. There you guys are. All right. Hey, Jen. All right, we got Brenda. We got Emily. Okay. Pear deck. Boom. Boom. All right. So I just sent you the pear deck, ladies and gentlemen. It should have popped up in your computer. All right. So let's take a look at the first one here. Write a number with 3 sig figs that ends in the hundredths place. All right. Stop. I'm getting you off that slide because that actually is where I wanted to start today. Bless you. Okay. All right. Because this is what we were struggling with on the worksheet yesterday, right? The end part of it. Some of us were, some of us weren't. All right. So over here, ladies and gentlemen, what I got is I got another way of us writing down the places, just so you know. I don't like writing out, especially when you get into hundred thousandths and thousandths and I just don't like writing those words out. So instead, I will use these numbers to represent them, just so you know. Okay? Now, there's a couple ways of doing this. Number one is it may ask you for a certain number of sig figs. Number two, it may ask you for a certain number of digits. Which one do you want to start with, digits or sig figs? Digits. Okay, digits. Give me a number of digits. Pick any number. Make it reasonable, though, please. Don't say 17. 5 digits. Okay? Quiet. 16. 5 digits. All right. Now, tell me a place where you want this number to end.
10,000.
All right. Let's go with the 10,000s. Good. Okay. So now there is a couple of ways you can go about doing this problem. We're trying to write a problem with 5 digits to the 10,000s place, right? 2 ways to do it. Way number 1 is I know the 10,000ths is 4 places beyond the decimal. So I can start by putting a digit in that place. I'm going to put a 7 in that place. Okay? So now I need 4 more digits, and they would have to be in front of that because I can't go any further to the right, correct? So now you could just fill in 4 more digits. There you go. There's a number with 5 digits that goes to the 10,000ths place. Okay? Now here would be the other way of doing it. Write a 5-digit number. 2, 3, 4, 5, 6. There's a 5-digit number, correct? Okay. Now I want to go to the 10,000ths place. So I know I have to be 4 places beyond the decimal. So now I could come and I could put my decimal in there. Either way, it's going to be a number between 1 and 9 something. And it's going to go 4 places beyond the decimal. Okay. So you could start either way. You could start with putting it in the right place like we did at the top, or you could start by writing the digits and then figuring it out. Questions?
No.
Okay. It gets a little more difficult when they want zeros in there. Okay? So let's take and let's say that we want zeros in a certain spot. Where do you want the zeros in this number? Beginning, middle, end, multiple places. Where do you want them?
Middle.
Okay, so we want zeros in the middle. All right, give me a certain amount of sig figs, and it has to be more than 3. It has to be more than 2. Otherwise, you can't have zeros in the middle.
Okay, 6. We can do 6.
All right, 6 sig figs. All right, what place do you want to end in? All right, let's end in the ones place this time. Okay, so I'm going to get rid of this. Oops.
Whoopsies.
Yep. Okay, so here's what our qualifications are. We have to have zeros in the middle. We have to have 6 sig figs, and we have to end in the ones place. Okay, now the only way we get in trouble with this number is if we, let's go back a minute. There's 3 places where zeros can be, correct?
Mhm.
If zeros are at the beginning of the number, they are what?
Never.
Never significant. And your number also has to be less than what?
1.
So we could not write a number with these qualifications that would be less than 1 because we're trying to end in the ones place. Okay? So again, zeros at the beginning are never significant, but they are there to hold places, and that number has to be less than 1. So you can't just put zeros in front of 100 to have more digits there. It doesn't make sense. Those don't count. Okay? The second place zeros can be is in the middle. What do we know about zeros in the middle?
Always.
They're always significant. So these zeros in the middle have to be part of this 6 sig figs. Okay? And the last place is zeros can be at the end. Okay? Now again, remember, you can have multiple zeros at the beginning, multiple zeros in the middle. You can have multiple zeros at the end as well. Zeros at the end are or are not significant.
It depends.
It depends on what?
The decimal.
If there is a decimal shown, they are. If there is no decimal shown, they are not. Okay? For this number to end in the ones place, okay, we want that number to end in the ones place. So our ones place has to be a digit in this case because we only want zeros in the middle that's not a 1 or not a 0. Okay? So again, we can start out by writing 6 digits. Give me 6 digits with a 0 somewhere in the middle of it, please. A 0 somewhere in the middle of it. Give me a number. Okay, but that's one number. I need 6 digits.
900,000. 900,000.
Okay, hold on. Mira, hold on. Cynthia was not finished, and I interrupted her. That is my bad. Cynthia, please go ahead.
7, 6, 3, 4, 8, and 9.
Okay, but we forgot one thing.
0.
We wanted a 0 in the middle.
Okay, change the 4 to 0.
Change the 4 to a 0. Okay, I can do that. Okay, so does this number have 6 sig figs? Okay. The next question is, does it have a 0 in the middle? Okay. And does it end in the ones place? And you're done.
Whoa.
That's it. You're done. Okay.
Actually?
Yeah. That would be it. Okay. What if we wanted this same number, but it's freaking out, ladies and gentlemen. Pick a different place. Pick a different place. Let's pick what? Thousands. So let's go with the thousands place instead. Oops, sorry, one too many O's.
That's not noticing here.
Okay, one too many zeros. All right, so that's 3 places beyond the decimal. What do I do to this number?
Move the decimal up 3 places.
To where?
Between the 3 and 0.
Use the exact same number, but put the decimal between the 3 and the 0. Okay? Exact same number, but put the number between, or the decimal between the 3 and the 0.
So what if we did hundreds? Would we put the decimal between 0 and 8?
Hundreds?
Hundreds.
Hundreds up here.
Yes.
Okay, good question. Okay, let's change this number so it is to the hundreds place. We would not put the decimal between the 0 and the 8. Because if we put the decimal between the 0 and the 8, that would be hundredths down here.
Oh.
You wanted hundreds up here, correct? Okay, good. because that's what I wanted to do next anyway. So first of all, I got to get rid of that decimal. Okay. Now, the problem with our number right now, our number has 6 sig figs, right? But it needs to end in the hundreds place, which means this 9 needs to be in the hundreds place, correct? So how do I make that 9 into the hundreds place? I add 2 zeros at the end. Now think about this for a minute. I added 2 zeros. That put this in the 100s place, correct? Still has 6 sig figs. Why? Why not?
Oh, wait.
There's no
after.
Because there's no decimal. Not
So
it.
if it would end in ones, it'd have to be a number 1 through 9, and then you add a 0 if it's 10, and then you add 2 zeros if it's 100, and then you add 3 if it's thousands.
Correct.
Oh.
So now our number is ending in the hundreds place, in the 100s place.
And
Okay?
if you added one more 0, it ended in thousands.
Correct. If I added one less,
It'd be
it
tens.
tens. Yes, perfect. Now, because these zeros are not significant, they don't change the number of sig figs. That stays the same. All they change is the value of this number. And that's what zeros are sometimes used for, to represent a value. Okay? So we put these zeros in, they're not significant. We still have 6 sig figs. We still have zeros in the middle, right? Okay? And we ended in the, now the hundreds place. That's what we would have to do. Questions?
No.
Now it gets a little bit more difficult if we want zeros where in our, or if we want zeros where in our number.
The beginning.
Okay, it could get more difficult there. Hang on a second. I got it. Rocio, thank you. Okay. Okay. It could get more difficult there. All right. Well, let's make it probably as worse as it can be. Okay. Let's make it as bad as it can be. So here's what I mean.
Zeros everywhere.
Let's put zeros everywhere. Now, if we're going to have zeros at the beginning, though, ladies and gentlemen, if we're going to have zeros at the beginning,
It'll have to be less.
it'll have to be a number that is less than 1. Okay? So we want zeros. Oops. Let's go beginning, middle, and end. Okay? All right. Now, how many sig figs do we want?
8.
Oh, my goodness. All right, we'll go with 8. Okay? Now, here's the thing about this one. To end in a certain place would be very difficult. Okay?
Four.
What?
Do 4.
Do 4 sig figs then? Okay. Even then, we're going to have to pick a place that is bigger or smaller than the 10,000s place. Okay? Because that's the only way we're going to get 4 sig figs in, and a number that is less than 0 is we got to get beyond the 10,000s place. So we could have done 8. That would have been fine. Okay? I probably wouldn't tell you it has to end in a certain place then. I would tell you that it has to have zeros at the beginning, middle, or end, that it has to have 4 sig figs, and that your number needs to be less than 1. Let's do that. Fair enough? Okay? So Nadia, we're going to do that, and then we'll write a number with 8 sig figs that is less than 1. So we got to start out 0 point something. Now, is that 0 at the beginning? So that meets that first qualification of zeros at the beginning. But how many more zeros do you want to put at the beginning? Pick a number, Cynthia.
4.
Or is it
5.
5? That doesn't make it better. But okay, we got it. There's 5 zeros at the beginning, right? Now you meant after the decimal, correct? Okay. If not, I could take one of these away. Is this okay? Yeah. Okay. So now I need to write 4 sig figs, and I still need a 0 in the middle. Could someone give me 4 sig figs that has a 0 in the middle of it?
3, 4, 0, 8.
3, 4, 0, 8. Okay, 4 sig figs that has a 0 in the middle of it, correct? Okay, but now I messed up because we want a 0 where as well.
On the end.
And if I put a 0 at the end now, what do we know about the 0 at the end if I put it there?
It'll only count if you have a decimal.
Well, but already look at our number.
So it'll count.
So it'll count.
So you have to give it an 8 the 0.
No, the middle one stays in the middle.
3, 4.
If I put
You
a
have to have-
slow down.
Oh shoot.
If I put a 0 at the end here, that doesn't change the fact that this 0 is in the middle. In the middle means outside of it there are 2 non-zero digits.
Oh wait, you can do 3, 0, 4, 0. Yeah.
Okay, you're right, and that's what we're getting at. If I want to put another 0 at the end, that 0 will become significant. Okay, which means I have to take away one of these sig figs. Now the one that I have to take away is either the what or the what. The 4 or the 3. I have to take away one of these two. Why? If I take away the 8 and put a 0 here, there's no zeros in the middle. Okay? So I have to take away the 3 or the 4, and I have to put a 0 at the end. So I'm going to take away the 4. Why? Because again, you get to pick this number. So it'd have to be 0, 8, 0. There is a number that has 4 sig figs, zeros at the beginning, zeros in the middle, zeros at the end, and it has 4 sig figs because the decimal makes the 0 at the end significant. Okay? Questions?
No.
Okay.
Is this gonna be like our quiz tomorrow?
Great question. Let me double check something. I know I asked you about sig figs. I don't know if I ask you to do this. I don't know if I ask you to write a number with sig figs. So hang on a second. I'm running out of screens here. Please. Okay. Really? I'm looking at your quiz right now, ladies and gentlemen, and I did not throw sig figs on your quiz.
No.
Measurements, okay, knowing what the meter measures, distance, okay, length, knowing what the units measure, knowing what instrument a unit goes with. So if you're measuring meters, what instrument are you using?
Meter stick.
Some sort of meter stick, some sort of ruler, things like that.
Yeah, that's it. That's it.
Hold on. The difference between base and derived units,
No clue what that is.
So they what?
they're the 7 base units right there. Any other unit is a derived unit. If you're multiplying units together, if you're dividing them when we talked about grams per cubic centimeter, grams per milliliter, those are derived units. Units that are found by multiplication or division of base units. Okay? And metric conversions. You're going to have to do some metric conversions.
Is that the one we divide or multiply?
Correct. Now, I will give you... I will- What? No, I'm not showing you the quiz right now, but thank you.
You look like a highlighter too.
Thank you. Later on today, I'm going to double as a yield sign.
Really?
Yeah, yeah.
Also, did you get a haircut?
No, I got them all cut.
Oh.
Okay. It's a lot cheaper that way. If you go get one haircut and they charge you like $20 for it, it's very expensive.
Oh.
The other line I thought about this morning is I always use that when people ask, did you get a haircut? No, I got them all cut. I was going to say, no. Amazingly, I got up this morning, my hair went back in my head and shrunk. No, but thank you. Thank you for noticing. It's good to know, you know, my wife comes home, I never noticed that she got a haircut. Okay.
Hey, that's fine.
Yeah, I'm not the kind of
I
person who
divorce you.
notices that.
I divorced you.
I'm amazed she doesn't. But anyway, ladies and gentlemen, there's so many things wrong with that, Nadia. So many things wrong with it. Anyway, yeah, I'm going to ask you to make conversions, but I will give you the facts that you need. So if I ask you to go from grams to milligrams, I will tell you 1,000 milligrams equals 1 gram. If I ask you to go from kilometers all the way to centimeters, I will give you 1,000 meters equals 1 kilometer. 100 centimeters equals 1 meter. I will give you the facts that you need to use. You just need to know how to use them. Fair enough? Hold on.
Are there going to be vocabulary terms?
Are there going to be vocabulary terms not that don't relate to the measurements and the metric and the metrics?
Not like inverse
We're-
relationship.
No, we're not. That stuff, no. I don't have any of that on this quiz.
Are we having any of this on the quiz?
Are we having what?
Any of this on the quiz?
No, again, I just looked at it because I couldn't remember if I had sig figs on your quiz or not, and I do not.
Are you serious? It's the one thing I'm good at.
Well, the good news is you'll be really good at the next quiz. I'm sorry.
I'm just going to bomb this one.
Really? You can't tell me what a stopwatch measures?
No.
Good. Then you should deserve to bomb this one if you don't know that a stopwatch measures time and the unit is seconds. Okay? All right. And by the way, you can use your periodic table with whatever notes you want written on it. I'm not going to ask you about the definition of chemistry, by the way. That'll be a question on your test, not on this quiz.
It's actually not on that periodic table.
What?
It's on that.
Yes, we will eventually have tests. Yes.
It is on there.
It's on that periodic table.
What?
Chemistry is a branch of physical science that studies composition, structure, properties, and change of matter.
Did you not know that?
Never saw that before.
You need
Oh,
to study
that's it.
Yeah, I saw
But
it like
I'm pretty sure you can
the
put that together. The
science,
study of the science.
the science of the study.
yeah, except for that the stuff the
The one thing it doesn't mention is, well, it does at the end, changes of matter. Right? So, okay. Again, good seating selection for you guys. Good seating selection over there, because that's the same periodic table on the wall over there. In the back there, sorry, you're screwed if you pick bad seats.
I can read. I'm not blind.
You can barely see the color of my shirt. How can you see that?
What do you mean?
I'm kidding. All right, questions. Moving on.
okay.
It was supposed to be funny. It didn't work out. Leave me alone. Okay? Leave me alone.
Okay.
All right. Number of sig figs. Give me a number. Give me a number. Jared, give me a number.
7.
You guys love what? Okay, 7
It's
sig
better than
figs.
14, so
Okay. The number has to be larger than
2.
10.
Oh.
Okay? Now, where do we want zeros?
everywhere.
No, actually, just the beginning and the middle.
Can't be.
Oh.
Well, because we can't be a number larger than 10 with zeros at the beginning.
Everywhere.
What?
The middle and the end.
Middle and end. All right. So first of all, start by giving me 7 sig figs with a 0 somewhere in the middle.
4, 3, 0, 2, 7, 8. I've lost count.
That's 6.
We're at 6.
9.
Okay.
So what you were writing off.
So right now we've got 7 sig figs. We've got a 0 in the middle, correct?
Yeah.
Now the one thing we haven't done is put zeros at the end.
Just put a zero.
0 and 7 9.
No, just
No,
add a zero.
if I put a 0 at, now we got to be careful.
And you put the-
We want to end in the tens place, correct?
Oh yeah, then put 0.
So now, if we put a 0, do we end in the tens place?
Yeah.
And did we add a sig fig?
No.
No, because there's no decimal here.
Yeah.
I can't put a decimal here because if I did, where would our number end?
In the ones.
It would end in the ones place. Okay? So sometimes we are going to add these zeros at the end, and we don't want them to be significant. Okay? We don't want them to be significant. We didn't say the zeros at the end had to be significant. We just said there had to be zeros at the end. Okay? Questions? All right. Now we can go back to what we actually started earlier. And that was our pair deck. Okay. So now try writing a number with 3 sig figs that ends in the hundredths place. Try writing a number on your computer, type it in, that has 3 sig figs that ends in the hundreds place. So remember, you could do the 3 sig figs first. I'm not asking anything about zeros. Nothing about zeros, okay? Aiden, do you need me to send this to you?
0, 0, 0. 0.00.
Yvonne, Jasmine, when you get your computers up, I'll send it to you as well.
Yeah, there's the decimal.
There's
Oh, wait,
no.
the first one isn't.
I don't.
Oh,
No, I don't.
1.01.
One.
All right.
Yeah, no. I'd put 3.1 for it.
Okay, 3 sig figs, number ending in the hundreds place. What is the smallest number that we could write with 3 sig figs ending in the hundreds place?
1.01.
Or 1.00 even.
Oh, that works.
Yeah, because the decimal.
Why?
Because the decimal.
Because the decimal makes the zeros at the end significant, right? Okay.
So one-
Now again, 1.01 would have worked as a number too. What is the largest number we can have?
9.99.
9.99. So when we're doing this, ladies and gentlemen, sorry, I need to get on the right screen here.
Yes or no?
Okay. We need a number between 1.00 and 9.99. That's what you should have written. Jasmine, did you get in?
I didn't write 7.
And Yvonne? Or not yet? I think it's, there's Jasmine.
This is what I'm gonna do.
And I think I got 7.99.
Look at the decimal for this. And I'm putting a 0 in there.
Yvonne, I still don't have you logged in yet for some reason. You can go to Pear Deck and just type in this code, but I'll send you it, Yvonne. All right. All right. So now our next one, ladies and gentlemen. Oh, sure. I'm on another screen. Now I'm coming back and forth. All right. Write a number with 3 sig figs that has digits, that has a digit in the thousands place.
Wait, I did you end the 1,000 place or add?
It doesn't say it ends in the thousands, but you have to have a digit in the thousands place, and don't put a 0 in the thousands place. That doesn't count. Has to have a digit in the thousands place, and only 3 sig figs.
So no decimal.
I just like add a decimal at the end. 1,000.
Don't add a decimal at the end.
That's,
It's more precise.
wait, is that right?
You are correct. It is more precise, but what is it going to do? It's going to make it 4 sig figs. So again, if you start out with a number
Oh, you need 3.
with 3 sig figs, pick a number, 7, 8, 9. Cynthia.
No, that's 0.
You guys are gonna make me
There's
quit
a bird
giving
right
warnings and simply put them in here like I should have Nadia doing right now.
That's why
There's a bird over there. Really? There's a little birdie over here too that says put it in your backpack.
That was a highlighter.
So the smallest number would be 1,010.
That's what
1, 0, 10, 1, 0.
Genius.
Okay? Largest number would be 9,999. Okay?
I
Now again, we can't put a decimal here. Why?
I bet you could add any 3 numbers and then add 3 zeros.
You could do that. I'm sorry, you could do that as well. I'm sorry. I just said that there had to be a digit in the thousands place. So if you wrote 999 with 3 zeros at the end, that has a digit in the thousands place. You are correct. I'm sorry. Yes, correct.
Yeah.
No,
Well, no,
because if you start going infinitely big, if you go over 999 and then 3 zeros, you're going to have 4 sig figs because you're going to become a larger number.
No, what
What if
if
you're just 999 and then a
and then a
bunch
bunch
of
of
zeros.
zeros with no decimal?
But that isn't in the thousands
I
place.
thought 0 was a digit.
No, there
One
would be
of,
a digit.
okay, sorry.
Shake my head. You guys weren't paying attention.
No. They're actually right on it, on their interpretation of this. What I meant is what Nadia did. One of the 3 sig figs has to be in the thousands place.
Okay, well.
Shake my head.
You said, again, you caught me on a technicality that is good because it means we're really starting to understand this. I didn't say that one of those digits in the thousands place couldn't be a 0. So yes. Okay, good. All right. Wow. Let's see if I wrote this any better. A number that ends with zeros and has a 0 in the middle and has 4 sig figs. A number that ends with zeros, zeros in the middle, 4 sig figs, no zeros at the beginning though. Doesn't say zeros at the beginning, so no zeros at the beginning.
Wait, 4.
You should take a look at my.
Can you see my
Yeah, you should take a look at my
Like
answer.
in my
Yeah, you should put on responses.
No.
Show responses.
Yes. Oh my God.
That one was mine.
I mean, not wrong.
That was mine. You're so proud of it. I like that you didn't scroll.
It is
That-
not wrong.
that was-
That is absolutely correct.
Hold on, I'll keep adding.
Wrong here. And now again, it's not showing you whose it is. What's wrong here? Please don't change it. See, we can't use that as an example now. I'm sorry. What the problem was? They had 4 sig figs, 8086, and then they put .00.
Oh, so the zeros at the end.
The zeros at the end then become significant.
Wrong. I'm so mean.
I know. It didn't come out the way I wanted it, but I really wanted to use it.
Still
for-
going.
Stop, Levi.
Okay,
This is
I'll delete
unfunny.
it. I'll delete it.
All of a sudden, it's gone. Okay. So now let's take a look at these. Good. Good. No. Why?
There's only
Oh.
something.
Oh,
Oh.
oh.
There was only. I don't know. I didn't see it.
1020.
Only 3 sig figs.
Correct. Now we could don't delete them. We can easily fix them. Let's talk about how we can fix them. Okay. Now
you need a
don't
zero.
delete. We still need a 0 in the middle.
There we go.
Okay, but now how many sig figs?
You need a 2.
No, don't put a decimal. Get rid of the last 0 and make it a decimal.
We don't know what it is.
I know. I keep looking up to see who's typing. Does that meet the qualifications now?
Yeah.
4 sig figs, zeros at the beginning, zeros at the end. Yeah, you can do this. By the way, no. Why?
Stop. Because the 0 would count after the
Correct. But we could take this decimal and put it anywhere in this number. After the 1, after the 0, after the 2, and it would have made the 0 at the end significant. Quick, let's get through these before somebody deletes them all. Good?
Yeah.
Good. Good?
Yeah.
Good. Hi, hello, how you doing? Good to see you. Deleted, I can't tell. Good. Good. All right. Questions?
Nope.
Obviously, there was. Okay, that one's good too. Wait. I gotta wait. Somebody's typing something for me. Oh, they changed their mind. Never mind. Okay. All right. So again, ladies and gentlemen, there are a lot of ways of writing these numbers. Okay. But we got to remember the basics, which is zeros at the beginning never count. Zeros in the middle always count. And zeros at the end sometimes count. And there are times when we want them to count and times when we don't. Okay? There are going to be times where we want those zeros at the end to count, and there are going to be times when we don't want them to count, and that's what we're going to try to show you today, ladies and gentlemen. Okay. Any other questions on the worksheet from yesterday?
No.
We're good? Okay. The answer keys are online. You can go online and you can check it, okay, to see if your answers were correct, okay? Or you could come see me about it. All right. So where we're at then, ladies and gentlemen, I'm on slide 49. Let's see where you would be because I know mine and yours don't match up. So you need to be on slide number 40. That is where you will be, ladies and gentlemen. Slide number 40. Okay. Now, because sig figs are going to play a role in measurements that we take, and then we are going to use those measurements sometimes to find something like density, mass divided by volume, to find area by taking length times width, okay? there are some special cases for when things are significant and when they are not. One of them is counting numbers. So if we count and we say, okay, there's 13 students in this class, how many sig figs would that be? 2. But that would limit our sig figs for future calculation. We don't want to do that. Now, the other thing is it is assumed that we all know how to count. You may have to teach a few people, but it is assumed that we all know how to count. Okay? So when you say 13, that is assumed to be an exact number, meaning 13.00000. Zeros go on forever.
Okay.
So they're infinitely significant. So don't let a counting number ever limit your sig figs. Okay? Second thing, when we have something like a conversion factor, 1 meter equals 100 centimeters. Well, 1 meter has how many sig figs in it? 1. 100 centimeters has 1 sig fig in it. That would limit our number of sig figs from that point forward. But what really 1 meter equals 100 centimeters means is 1.0 forever meters equals 100.0 forever centimeters. So we never let a conversion factor limit our sig figs. Okay? They are considered to be infinitely significant. So just because it's 1 meter, if you're doing a conversion factor, we don't let that limit our sig figs. You can totally ignore that for sig figs. Okay? And then, ladies and gentlemen, the last one is if you have a number in scientific notation. Because the start of that number always needs to be greater than 1, but less than what?
9. Or less than 10.
Less than 10. And then if you have another digit, there has to be a what? If you have 2 digits in a number in scientific notation, what has to be between the 2 digits? A decimal. So right away, there's a decimal in that number. What does that mean for any zeros in that number? They count. But only the ones that are actually shown. Not the times 10 to the 4th. This would have 3 sig figs. We ignore the times 10 to the 4th and we look at this. What this allows us to do, ladies and gentlemen, is control sig figs with scientific notation. In other words, there are going to be some numbers that the only way you can write them in the correct sig figs is to put them into scientific notation. Okay? This number here, well, let's start with this one. How many sig figs?
3.
3. Okay? 3. How many here?
2.
2. And how many over there? 4. Okay? So, sorry. I heard O. I didn't know what O meant for sure. Okay? All right. So think about this, ladies and gentlemen. Let's say you had a number like this. Your answer came out to be something that is written down, 2,500. And you're supposed to show that to 3 sig figs. Now, we'll get into explaining how you determine the sig figs in a little bit. But I can't put a decimal at the end. Why? That would be 4 sig figs. And I can't do just 2, 5 because that's only 2 sig figs, correct?
Yeah.
The only way to put this number into 3 sig figs would be to write it in scientific notation. 2.50 times 10 to the 3rd. And that is another reason that we have scientific notation, ladies and gentlemen. It's not just to get rid of all these extra zeros in a really large or really small number, but it lets us sometimes control our sig figs. We will almost never have to do that in here, hopefully. Okay? I can't guarantee it, but that is another reason to use scientific notation. It is the only way to express this number to 3 sig figs. Remember, I wrote it without the decimal originally. We put the decimal, it becomes 4. Okay? And you can't just make it 2,510. You can't be like, well, I'll just make it a different number. I'll make it a different value because that wasn't your measurement. Okay? That wasn't your measurement. All right? Questions? Good. All right. And here's the key. When you are rounding a number, your answer should have no more significant figures than the data with the fewest amount of sig figs. Okay? So there are rules for when we're rounding. And when we're rounding, we're either going to round to a place. What I mean by that is if we round to the tenths, or if we round to the hundredths, or if we round to the ones. We have a set of rules that says we will round to a place at times. And then we have another set that says we will round to a certain amount of sig figs. We will round to 2 sig figs, or 3 sig figs, or 4 sig figs. We will explain the rules to you tomorrow when we get into the math with scientific notation. Okay? But right now, we're going to talk about rounding. So, first of all, when we're rounding, this is the same rounding you would do in math class. Okay? In math, if you are rounding to the tens place, count from 0 to 100 by tens, Cynthia. So our number has to end like that. It has to end 10, 20, 30, 40, 50, 60, 70, 80, 90, right? Okay? When we're rounding, though, we always look one place beyond where we're rounding to determine if we leave that number in that place or if we move it up, correct? Well, the rule is, same in math, you find the place that in that number, okay? So if we're rounding to the tens place, we find the number in the tens place. You look at the digit to the right of it. If the digit to the right of where you are rounding is 5 or greater, what do? We raise it up. If the number is less than 5, we leave it. We leave it. Now, I will tell you this. That's not right for science. We're not going to get that specific, but technically in chemistry, if your number comes out to be 5, you have to go one more digit. We're not going to do that. Okay? If your number in chemistry were actually to be a 5, you have to go to the next digit. If the next digit is odd, you leave it. If it's even, you would round up. We're not going to get that crazy about this. Okay? We're not going to get that crazy about this. Okay? 0 through 4, we leave it. 5 through 9, we round up. Okay? Basic rules of math. Okay? So, what digit is in the tens place in this example? If your number in your calculator came out 12.346, Rocio, which of those digits, the 1, 2, the 3, the 4, the 6, is in the tenths, 0.1 place? So which of these is in the tenths? Just to the right of the decimal. Nope. This one is the tenths. The 3. Okay? So the 3 is in the tenths place. So that is where we're rounding. Now, what is the digit to the right of that? A 4. So, since this is a 4, are we going to leave our number or are we going to round up? We're going to leave it. So what would our final answer be? 12.3. 12.3. Easy peasy, right? Hardest part, figuring out what place we're talking about. To be honest, I know you guys haven't done places in a long time. Okay? Haven't done places in a long time. All right, the number 4,256.589. What digit is in the ones place here? What digit is in the ones place, Jacqueline? The 4, the 2, the 5, the 6, the second 5, the 8, or the 9. In the ones place. The 6. Perfect. Okay? Now, Nadia, what is the next digit to the right of the 6?
I don't know, to be honest.
Okay, well, here's the 6, right? Okay, to the right of it, what's one more past it? The next digit over.
Oh, like what it is? Or
What is it? Yes, what is the number? I'm sorry.
Oh, 5.
5, thank you.
Okay.
Sorry. Okay? So since that number is a 5, Brenda, are we going to leave that a 6 or are we going to move it up to a 7? Because the number after the one we're rounding to is a 5. Are we going to leave the 6 as a 6 or are we going to round it up to a 7? Nope. If it's 5 or higher, we round up. If it's 5 or higher, we round up. So what would our final answer be here, Leaf?
It would be 4.257.
Why did you put a decimal in there?
Not, I didn't mean to put that.
Okay.
Ignore it.
So what is it?
4257.
4257. 4257. We're rounding to the ones place. Our number has to end up in the ones place. We rounded to the tenths. Our number has to end up in the tenths place. Questions? All right. So what if we are rounding the number 23,012 to the tens place? Which digit is in the tens place here, Jasmine? Which of these digits? The 2, the 3, the 0, the 1, or the 2? The 1. All right. What is the digit just to the right of that, Aiden? What is the digit just after the 1? 2. So are we going to leave that 1 as a 1, Haley, or are we going to round it up to a 2? We're going to leave it. Okay. Now, here's the question. How do we write this number to the tens place? 23, 10.
23,010.
23,010. Why did I put the 0 back here?
Because you're rounding up in the 10 spot, not the ones.
Correct. Now, remember what Cynthia told us earlier. If we were counting by tens, our number has to be 10, 20, 30, 40, 50, 60, 70, 80, 90, right? People ask me all the time, well, can't I just make this 2,301? No.
That doesn't
You
make
wouldn't be happy with your bank if they took your $23,000 bank account and gave you $2,300 and said, "Here you go, happy on your way." Don't change the value of the number. We're rounding it, but we're not changing the value of it. Okay? Questions? All right. Where's the thousands place, ladies and gentlemen? How many beyond the decimal? 3. So which digit in this number is 3 places beyond the decimal, Brindley? The 2, the 3, the 6, or the 8? The 6. Okay? And I guess everything's going to come in right away here, ladies and gentlemen. There's an 8 afterwards, so we're going to round the 6 up. We round it to a 7.237. Questions? Okay, now we got a problem with the next number. What's the problem with it?
There's no 100.
There's no hundredths place. So what do?
You add zeros.
We put in a decimal and we add zeros. Your calculator doesn't know anything about sig figs. Well, maybe some of the newer ones do. But most calculators don't do sig figs. They do math. Now, I know that 12 and 12.00 to a math teacher are exactly the same thing. And I'm not saying they're not the same value. But what is different about this number and this number?
Just there's a decimal.
Yeah, there's a
Okay.
decimal, so there's more sigma figures.
Thank you. This number has how many sig figs? 4. This number only has... Don't lose sig figs when you do your math. If your number is supposed to be to the hundredths place, there is a reason for that because our measurements were to that place. Okay? Don't lose them. All right. So the next one, ladies and gentlemen. Now we're rounding to the hundredths place. What digit is in the hundredths place here, Rocio? Which digit is in the hundredths place? 2 beyond the decimal. Which one, the first or the second? Sorry, I put 2 9s in there. The second, okay? So the second, what's the digit after it, Gerald?
8.
So what are we going to do to it, Miro? We're going to round it up or leave it? Up. But when we round this 9 up, what does it become?
10.
Be careful. More than 164.
1.00.
Thank you. 164.00. Okay? Don't lose the sig figs just because there's zeros at the end. Okay? We were trying to go to the hundredths place. There's a reason for that because our instruments told us that we had to go there. I know 164 and 164.00 would mean no difference mathematically, but in sig figs they do. Questions? Okay. Now, sometimes instead of rounding to a place, ladies and gentlemen, our rules are going to tell us you have to round to this many sig figs. Now, again, the rules, even though they are changing, rounding does not. We find the digit that is that number of sig figs. So if we have to round to 3 sig figs or 4 sig figs, we find the third, we find the 4th sig fig in our number. We look at the number, the digit after it. If the digit after it is 5 or greater, we're going to round that number up. If it is 0 to 4, we are going to leave it. The rules don't change, just how we're deciding where to round does. By the way, once you find your third sig fig, if we're rounding to 3 sig figs, all we're really doing now is rounding to that place. Okay? All we're really doing is rounding to that place. Okay. So 12.346. We want to round this to 2 sig figs. Our rules say that's all we can show. What is the second sig fig in this number? What digit? The 2. This is the first sig fig. This is the second. Now, what's the only time when the first digit isn't going to be the first sig fig? If it's 0. That's the only time. So you got to find a non-zero number and you start counting there. All right. What is the digit that is after the 2? 3. So are we going to leave that to a 2 or are we going to move it up to be a 3? Are we going to round it up? We're going to leave it. So what's our final answer? 12. That's it. 12. Okay? So even though we said we were rounding to 2 sig figs, once we find that place that the 2 is in the ones place here, it's like rounding to the ones place. It's like rounding to the ones. 4,256.789. To 3 sig figs. What's the third sig fig in there, ladies and gentlemen? The 5. What is the digit right after it? So what do we do to that 5? We're going to round it up. So what does our answer become? Which one?
4260.
4260. Don't, Nadia just wanted to give her bank a few $1,000s. All right? Don't change the value of the number. We still need the 0 in here. Okay? We need the 0 in here. Otherwise, our number goes from being 4,000 to being 400. Now, I'm not arguing that this number has 3 sig figs and the number 426 has 3 sig figs. I'm not arguing that. What I'm arguing is that we would be changing the value of that number. We do not want to do that, ladies and gentlemen. We do not want to do that. Okay. The problem with this number is we want to round it to 3 sig figs, but how many are there?
2.
So what do we do?
Zero.
And the decimal.
We are going to add a 0. Now, is that 0 significant here?
Yeah.
Yes, and that's fine. We want that to be significant. Okay? So all we do is put a decimal in and put the 0 in. Okay? That is all we end up doing, ladies and gentlemen. The next one. 0.2368. How do we round that to 4 sig figs? It's already there. We don't have to do anything to that one. Sometimes your calculator is going to give you an answer in the right sig figs purely by accident, ladies and gentlemen. That's the way it's going to work out. If it does, go with it. Okay? How would we do 12 to 4 sig figs? We would add 0.00 to the end. Put the decimal in and put zeros. The zeros are significant. Okay? The zeros are significant. Okay? And they're not changing the value. They're just changing how many sig figs are there. Okay? Here, the 0 was not significant, but it was needed to maintain the value. All right. 163.998. 5 sig figs. 164.00. The second 9 is, again, the 5th sig fig. There is an 8 after it, so we're going to round that 9 up. Again, don't change it to 164. This is also why, ladies and gentlemen, I warned you when you're in back and you're looking at a balance and it reads 0.000, don't drop the zeros. I know that doesn't change the maths, but it does change the sig figs in your measurement. Don't do that. Don't do that.
Why are sig figs important?
Why are sig figs important? Because they say to somebody that this number actually has meaning. Okay? If you take 10 divided by 3 in your calculator, you get 3.3333 forever. Forever, right? It's a repeating number. But in reality, in a measurement, only so many places have value. Only so many places have meaning because you actually measured it. Okay? And that's what sig figs are. Each of these digits I measured. I didn't just get them out of a calculator. Okay? Christian, how are you, sir? Good. Okay? Take out your headphone, please, sir. Come on in and join us. It's good to see you here for a change. Excellent. We were going to send out a rescue party, Christian. We were. All right.
Yeah, that's me and my
Okay. Questions. This will become a little bit easier when we actually start making measurements with sig figs. Okay? And here's the problem. Our balances read to 3 places beyond the decimal. So when you measure something on a balance, you're probably going to get about 5, maybe 6 sig figs out of your number. But when we use a ruler or a graduated cylinder, we may only get 3 sig figs. So if you're taking a number with 6 sig figs and dividing it by a number with 3, we can only use a certain amount of those sig figs. Okay? We can only use a certain amount. We'll explain what the rule is later. All right. Oops, sorry. Scoop. All right. So, all right, you've listened to me long enough today. Okay? In Google Classroom, ladies and gentlemen, there is a second assignment for you in Google Classroom today. Go to Google Classroom and find the assignment that says Significant Figure Rounding Worksheet. Open it up, ladies and gentlemen, and here's the worksheet. Okay? Here's the worksheet. You've got about 13 minutes. You could probably get the worksheet done. What I want you to do, though, is, again, take this number and round it to 2 sig figs. What's the second sig fig in this number? 3. The number after it is, the digit after it is a 1. So what would this number be rounded to 2 sig figs? Good. What would it be rounded to 3? Good. What would it be rounded to 4?
23.14.
Good. So that's what I'm asking you to do on here. I'm asking you to go through here and to round these to a certain number of sig figs. Okay? Then on the bottom here, though, I switch. We're going to round to a certain place, to the tenths, to the hundredths, to the thousandths. So you're going to go through and you're going to practice some rounding, ladies and gentlemen. So let's give you a little bit of time to get this done. If you have any questions on anything, you can call me over and I can answer them. And that's going to be where we finish for today, ladies and gentlemen. Okay? That's going to be where we finish for today. So go to work, ladies and gentlemen. If you have questions, please call me over.